Hello and welcome to this video lecture on Chapter 8. Today we're going to talk about keys, the different type of keys that you can have in your database tables. And so specific things that you should take away from this lecture and from your readings in the chapter is why are the keys important? What kind of keys do you want to establish for each table? What kind of table level integrity do those keys provide to you? And then we'll review the initial table structure. So keys are important because they help establish the identity of each record. And remember, a record is a row. And so if we look at the relationships in an Access database, we can see what the primary keys are here for these different tables. What you need to understand is this driver ID uniquely identifies each record in that particular table. So that's what we're talking about here. They also help to establish and enforce the different types of integrity. And what we mean by integrity is they help you to ensure that the table has unique records. You don't want to keep putting in the same information over and over again and maybe change one or two fields so it looks differently. If we know that there's one unique primary key for that particular record, then we're not going to repeat it again because we'd have to repeat that primary key because it uniquely identifies that information that goes with that subject that's in that table. They also make sure that the tables and relationships have matching values. So that way we're only limiting the amount of data that we're repeating in our database. That is, the primary key and foreign key fields match up. And what I mean by that is if we look at driver ID here, this is the primary key, so every record has a unique driver ID. But here we're repeating that information again, but this time driver ID isn't unique inside of this record. We might have multiple records that have the same driver ID. But for this particular table, we're only going to use insurance ID for its primary key. So every record would have a unique insurance ID. So those keys then are used to establish links or relationships between the tables. These tables are called tables when you're in the physical design of your database. When you're in the logical design of your database, they're not called tables, they're called entities. And an entity is a person, place, or thing, or an event that you're keeping track of. So that's what we've got here. In this particular case, they're tables for sure. But we could also refer to these as entities in a relationship diagram. So when we look at the keys we need to establish for each table, each key type determines its function within the table. There are 4 types of keys that we're going to talk about, and these are the types of keys when you're coming up with your primary key. There are candidate keys, primary keys, alternate keys, and non-keys. So before you select a primary key, you need to identify what keys, and that means fields or a combination of fields, will make a good primary key. Those particular fields are known as candidate keys before you select a primary key. Each table has to have at least one candidate key, and then you'll look at that pool of candidate keys to select one of the keys to be the primary key. So what does it take to be a candidate key? Same thing it takes to be a primary key. So the data inside of a candidate key cannot be a multi-part field. It has to contain unique values, that is, from record to record, it has to be unique. Can't be repeating. It can't have any null values. The values in that field can't breach any of the organization's security or privacy rules. Example there is if you're using Social Security number as a candidate key, that would violate privacy rules because now whoever's looking at that would know that piece of information and can use it for, bad reasons. It also cannot be optional in whole or in part. So part of that value in the primary key or candidate key cannot be, partial. You don't need to have partial information there. Also, the makeup is a minimum number of fields necessary to define uniqueness. Right? So it's generally what you want to do is create a surrogate key instead of a complex key. And a complex key would be is, let's say you were creating a table for doctor's visits. And so you couldn't uniquely identify everything. And so you might come up with a key that's a combination of the doctor's name, the date of the visit, and the time that it was taking place. Well, that's fairly complex. And so a surrogate key is a key that you could use to represent a candidate key, and it isn't as that complex. We've seen examples of this, and that would be the auto number. So if you see what I've got written here, when you determine that the table does not contain a suitable candidate key, you can create an artificial key, and we call that a surrogate key. It's artificial because it doesn't naturally occur in the table. You have to produce it or manufacture it. Again, like I said, is when you do an auto number, that's the data type, the database automatically creates a number for you that's unique for that field, and that's what you use as the candidate key then. Some other elements of a candidate key, I think we've hit on this one repeatedly. It's got to be unique, and it exclusively identifies the record. It must be exclusively identified the value of each field within a given record. So what that means is that if I know that value, then the non-key field should then be determined by that value. Then the last one, its value can be modified only in rare or extreme cases. You don't want it to be changed a lot. So if we go back and look at our database, I just want to know, let's say we have insurance ID here as this value. If I know this piece of information, then I should be able to get to every one of these other pieces of information. That's what we mean by the non-key fields here. That is, this particular element then, that candidate key exclusively identifies the values of each field within the given record. All right. So the next type of key we might have is the primary key. So the primary key uniquely or exclusively identifies the table throughout that database structure. It's going to be used to help establish relationships with other tables. That's how the link is done. It has to be unique for each record, so it uniquely identifies that record. It has to conform to the same elements of a candidate key. And the values of a primary key will serve as a foreign key in one or more additional tables when it's being used to create a relationship between tables. And so that would be this example here. So we've got driver ID as the primary key here, but since it can repeat, the data can repeat within this column, it acts as a foreign key here. Now, in your homework assignment for this week, I think you're going to have an example where you're linking some tables, but the names are not the same. What's important when you link tables is that the data types and the data have to be the same. The actual name of the column doesn't have to be the same. All right, so some guidelines for selecting the primary key. If you have a simple candidate key, that it's only a one single column or field, and you have another choice of a composite candidate key, that is, you're using more than one field together to make up the primary key, then you choose the simple one. So I'll go back to here, and an example would be is if you saw a concatenated key, something that's combined, you would see two of these little key symbols next to it. We see those examples when you have an intermediate table connecting a one-to-many and many-to-one relationship, thus representing a many-to-many relationship. That would be a concatenated key or a composite key. So that's what they're talking about here. You would also, when you're selecting your primary key, you want to choose a candidate key that incorporates part of the table name with its own name. And that's just sometimes used for identifying that primary key. Some other guidelines for selecting the primary key is choose the one that's least likely to break one of the candidate key criteria in the future. So if we look at those criteria for candidate keys, think about if you're changing data or need to add to your database or modify it, which one is going to least likely have to be changed in the future. So once you establish that primary key, you've got to make sure it'll do the following. So each table has to have only one primary key, and this is confusing for people that are just talking or getting used to talking about databases. You got to have one primary key that uniquely identifies every record. But just because I say one doesn't mean that's one field. Typically it is one field, but you could have a combination of fields that make up the primary key. That primary key has to be unique, and no two tables should have the same primary key unless one of them is a subset table. And again, subset table means you're linking it back and there would only be a one-to-one relationship there. So we've been talking about candidate keys and primary keys. So you get your list of candidate keys. From there, you're going to select a primary key. Once you've selected a primary key, the other candidate keys now become known as alternate keys. And so that can help you later on in your database design if you want to use an alternate key in terms of your links. The fourth type of key here is the non-key. And the non-key, well, sometimes I like to call the non-key field, are fields that don't make good candidate keys, primary keys, or alternate keys. And so they become those other fields in your record. But in pure database terminology, it's the ones that weren't going to be used as candidate keys. So in our case here, we have insurance ID, then these don't become good candidates for primary keys, so they become non-keys. The last thing in this chapter is for thinking about table level integrity. And this type of integrity is a higher level type of integrity, and it ensures the following, and I've been talking about this all along, that there are no duplicate records in the table. The primary key exclusively identifies each record. It's unique, and it can never have a null value. And so given this information, then that'll make it easier to talk about Chapter 9, which deals with the other types of keys, which is mostly your non-key and your foreign keys. All right, we'll start Chapter 9 next.